Hi everyone. In today's lesson, we're going to talk about a concept called common bases. So these are called exponential equations. So what an exponential equation is an equation that contains a power with a variable for an exponent. So for example, we have 2 to the 2x, where my variable is in my exponent, 5 to the x minus 1 equals zero point zero 0.04. These are all considered exponential equations because they have a power with a variable for an exponent. So the general rule states if we have two bases that are equal, b and b, then it implies that their exponents, n and m, are in fact equal. And the real reason for that, I can show you through an example. So if I had given you, say, base of 5, exponent of x, and base of 5, exponent of 2. It's clear that if 5 to what power equals 5 squared, well, if the bases are equal, then it must imply that the exponents must be equal. So this would imply that x must equal 2, right? 5 squared must equal 5 squared. So that works. Now, that's the most basic concept of a common base problem, and obviously they'll get harder, but that's really where it stems from. So before we can get into more examples, we actually have to talk about how we can rewrite a certain number using a different base. So for example, the number 4, we could write 4 as 4 to the first, but that's using a base of 4, right? The base is 4, the exponent is 1. But what if we used a different base, say 2? You guys know what 2 squared is, right? 2 squared gives me 4. So 4 is the base, 2 is the base, and 2 is the exponent. So there's really only one other way, 2 squared, to write 4 other than 4 over 1. Let's try 8. So we know 8 is the same thing as saying 8 to the first. So that's writing 8 as a base of 8. But we could use a base of 2 also. We know that 2 to the third also gives us 8. So what that does is we're rewriting this as a base of 2 with an exponent of 3. Same thing for 9. We could write it as 9 to the first, or you know 9 as 3 squared. So my base is now 3, and my exponent is a 2. So we've got 3 squared, which also equals 9. 16 is a good one because we actually can use multiple bases. You can use 16 to the first, right? That's the most common one. And we can start with a base of 2. I know that 2 to the fourth gives me 16. I know that 4 squared also gives me 16. So here are two different ways to write the same number. So my base is 2, my exponent is 4. Same thing here, base is 4, exponent is 2. So we can do the rest. I'm just going to show you what they are. 25 could be 25 to the first, or 5 squared. 27 is 27 to the first, and it could also be 3 to the third. 32 can be 32 to the first, and it could also be 2 to the fifth. 64 is a good one because there's a lot of options here. So 64 to the first works. We could do 2 to the sixth. We can do 4 to the third. And we could also do 8 squared. So 64 actually has a lot of different bases that we could use. 81 could be 81 to the first, or it could be 3 to the fourth, or the more common one, 9 squared. So these are all different ways that we can rewrite these numbers up here using another base. Now, what if I gave you a number that was a fraction? So like 1/4 here instead of 4. So 1/4 is the same way that you would tackle 4, except the only thing you're going to do is you're going to negate the exponent. So you see up here in number 4, up here at 4, 4 was the same thing as saying 4 to the 1 and 2 squared. So all we're going to do to write that one is we can write this as 4 to the negative 1, or we could write it as 2 to the negative 2. Same thing with 8, or 1 over 8. 1 over 8 is going to be the same thing as writing 8, except it's going to be 8 to the negative 1, and 2 to the negative 3, and so on and so on. So the rest of this chart would be the same as above. So just negate the exponents. So we have 9 to the negative 1, 3 to the negative 2, 16 to the negative 1, 2 to the negative 4, and 4 to the negative 2. So the general concept here is if you have a fraction, you really want to treat it the exact same way as if you had a whole number, just put the exponents to be negative. So take a minute and finish this chart using the negative exponents, and then hit resume when you're ready for the answers. All right, this is what I got. So take a minute and compare your answers with mine, and if you need to fix anything, pause the video and do so. All right, I think we're ready to do some examples now. So examples say the directions, solve each exponential equation and then check your answers. So I'm not actually going to do the checks. The checks are really going to be for you to see if your answer is right. There's nothing that's going to need to be rejected. You just want to check it to see, if you did your problem correctly. So what we notice in problem number 1 is that the bases are already the same. So since the bases are the same, the exponents must be equal. So a little trick that I like to do is we cross off the bases and set the exponents equal. So 2 must equal x. Okay, fine. We kind of did that one before. How about number 2? So if you notice, the base in problem number 2 here, this is a 2 and this is an 8. The bases are not equal. The goal is to get them to be equal. So you want to think to yourself, how could I rewrite 8? Well, from the front page, you can know that 8 is the same thing as saying 2 to the third power. So by doing that, the right side is 2 to the 2x, and now the left side is 2 to the 2x, and the right side is now 2 to the third. So since my bases are equal, I can cross them off and set the exponents equal to each other. So 2x equals 3, and I can solve by dividing by 2. So x is equal to 3/2. Now, I know I said I wasn't going to do the check, but if you wanted to, you could, plug it into the original equation. So you'd plug in x to be 3/2, and you want to see if you get 8. So if you put this into your calculator, you should get 8, and 8 equals 8, so it checks out. All right, let's look at number 3. So number 3, same thing, solve for the exponent. But right now my bases are not equal. I have a base of 4 and I have a base of 8. So you basically want to ask yourself, can I rewrite 8, the bigger number, with a base of 4? Well, I don't think so because 4 to the first is 4 and then 4 squared is 16. So it's too big. So now we're going to drop down to 2. 2 to the second we know is 4 and 2 to the third we know is 8. So this is actually going to help us. We're going to use both of them. So we're going to rewrite this 8 as 2 to the third, and we're going to rewrite this 4 as 2 squared. But that base is already being raised to this exponent of a, and this exponent of a plus 1. So we're going to take the 4 and raise it to the a power, and we're going to take the 8, or the 2 to the third, and raise that to the a plus 1 power. And now we have to use the properties of exponent. When I'm raising a power to a power, the rule is that we multiply the exponents. So 2 to the 2a must equal, and now we need to multiply 3 times a plus 1. So we're actually going to distribute the a to both, the 3 to both. So it's going to be 2 to the 3a plus 3. And now that the bases are equal, you can cross off the bases and set the exponents equal. So 2a equals 3a plus 3. We're going to subtract 3a on both sides. We're going to get negative 1a equals 3. And we're going to divide by negative 1. So a would equal negative 3. All right, how about a question like number 7? So we have an exponent that happens to be, not an exponent, we have a base that happens to be a fraction. So this 1/2 we need to rewrite so that it has the same base that I could rewrite 8 with. So I know that 8 is equivalent to 2 to the third. So I'm going to try to use 2 because I see a 2 here. So I know that 8 can be written as 2 to the third. So I'm going to write 8 as 2 to the third, and I need to raise that to the 2 minus x power. And I know that 1 over 2 is the same thing as saying 2 to the negative 1. And if that's difficult for you to see, here's an explanation on the side. So we know that 1 over 2 is the same thing as 1 over 2 to the first, right? So I could bring this upstairs, and then that makes the exponent negative. So that would be 2 to the negative 1. So that's a reason where that comes from, and I'm forecasting to look at number 8, same thing. 1 over 3 is the same thing as 1 over 3 to the first, which I could bring upstairs and make that 3 to the negative 1. So let's go back now to solving. So we need to just continue the pattern here. We need to distribute this 3 to both of the pieces. So it's going to be 2 to the 6 minus 3x. And now that the bases are equal, we can cross them off and set the exponents equal. So it's 1 equals 6 minus 3x. So we're going to subtract 6 on both sides. 1 minus 6 is negative 5. And then we're going to divide both sides by negative 3. A negative divided by a negative gives us a positive. So my answer should be positive 5/3. All right, that's it for tonight. So why don't you guys try to see for homework, maybe if you can do question number 8 and question number 4, and we'll go over that in class tomorrow. So we'll call this one homework and this one homework. All right, have a good night.